So good morning and welcome. We'll be starting our webinar up in about 2 minutes for those of you joining us via Zoom. Thanks. Good morning. We'll be starting up in about another minute for those of us joining us via Zoom. Got a good mic there, Ed. Picked up everything.
Even my slurping coffee?
That's it, Ed. You put it down on your table. Yeah. Well, that's good. Better to have too good a mic than one that wavers out. So.
Yeah. I'm wired here with internet, so and it's 100 megabytes, so it should be okay.
Okay, sounds good. Okay, so good morning and welcome to our Tuesday webinar. My name is David Orr. I'm a director here at the Cornell Local Roads program, and we're doing today's webinar on full depth reclamation. Joining me today is Edward J. Dennehy, and I'll let Ed give you a little bit of his bio. Go ahead, Ed.
Sure. As Dave said, my name's Ed Dennehy. I've been around this industry for longer than most of you guys have been alive. I started working for the town highway department when I was a freshman in college in 1969. So I spent 36 and a half years at the DOT, and then I worked 10 years for a contractor who did full depth reclamation amongst other processes. Back to you, Dave.
Yep, no problem. So what we're going to do, just to help us out, we'll start our first poll. If you've been on our webinars before, you've seen these questions. So how many folks are at your site? I work for is a multiple choice. And then how long have you been with your agency? And for those of us who are joining us via Facebook Live, you can't join in the poll. I apologize, but still welcome and thanks for joining us today. And we'll wait until we get about 3/4 of the folks up, and then we'll share the results of that poll. Make sure you scroll down and answer all 3 questions. Okay, there's 4 or 5 seconds. Okay, we'll end the polling, share the results. So as has been fairly typical, about 3/4 of you are by yourself. There's quite a few of you with 10 or more. Thanks for joining us. Today's 3/4 working for local government, the rest working pretty much for a consultant, and 1 honest person working for the weekend. And then quite a range of experiences from 10 years to a few new folks. Okay, cool. That's very helpful as we're trying to answer your questions. We know what your background is. Okay, we'll be using the poll a couple of more times during the course of the day. Okay, so we're going to start with full depth reclamation. Full depth reclamation is not the FDR, as we call it. It's not the president. It's a different term in the world of highway engineering. Just a couple of acknowledgments, some resources that you might look at later on. A couple from the New York State Department of Transportation, from the Geotechnical Bureau. One is their general engineering manual, and then there's a whole bunch of design manuals and guidelines that they've got. We'll add links to all of these resources at where we put the recording on our information highway on our website, which we'll give you at the end. We also are going to be pulling some stuff from a couple of our workbooks, specifically Asphalt Paving Principles, and then gravel tech tips that we've got on our website as well. Now, for those who are interested and curious, just a couple of reminders. We've disabled the chat, but you can raise your hand. We'll be asking you to do that a couple of times. And if you have a question, please put it into the Q&A pod down near the bottom of the screen. Those joining us on Facebook, you can put your questions in there and they'll get transferred over so that we can see them and answer them for you. There are professional development hours. If you're an engineer, you're looking for those. It's going to be 1 PDH, but only the person who's registered is able to get it. And what will happen is it is a course, and we will send you the certificate of attendance after you send us your certificate of attendance for attending today's session. Anybody who stays on for at least 3/4 of the time will send you that. But if you need a PDH, you need to stay on the entire length, and we'll send you the PDH afterwards. If you're from another state, out of state, and you're looking to get a PDH, well, you'll need to check with your LTAP center in your state to see what's available. Now, before we get into FDR, I just want to quickly remind you where this fits in the world of asphalt repair options. Everything from doing nothing all the way down to total reconstruction. FDR fits in down here near the bottom as a reclamation technique, okay? So we've talked about these repair choices in previous webinars, and just a couple of reminders of the more critical repairs that we need to always think about in the back of our mind, because we don't want to jump right to full depth reclamation. We want to think about sometimes doing nothing. I like doing nothing myself, Ed, because it's easy and it's cheap. And I use it on my good roads and my bad roads. Here's a slurry seal, for instance, not too far out of Schenectady. Doesn't need any work. It's in great shape. It's a paved road with a slurry seal on it. It's going to be in good shape for many years. On the other hand, here's a road where in an urban environment that there's no point in doing anything. FDR wouldn't work here. It's too far gone. You really need to probably reconstruct it. And especially in an urban area, you need to make sure the utilities underneath are in good shape before you put a lot of effort and time in. Always going to bring up drainage. You know, there's only 3 things that matter. What are the 3 most important things when it comes to drainage at roads, Ed? Remember that joke?
Yeah, drainage, drainage, and drainage.
Absolutely. See, he can read my mind. And then, of course, our famous picture from Saratoga Springs that the gentleman named Jay Olson took that says drainage is critical for roadway design and ducts are an indicator of poor drainage. So everything we're going to talk about today, please keep in the back of your mind. We got to have drainage for all of this to work. And we don't have that. Really, we don't want to be putting a lot of effort into the techniques we're going to show you. Now, some people think of recycling when we talk about FDR or reclamation. We're not. I like recycling. It's environmentally friendly. We recycle over 1 billion tons annually in the United States of asphalt concrete. It fixes the cracks in the surface, but it's not fixing the base. And so when we're talking about recycling, that's not what we're talking about today in reclamation. And of course, there's lots of choices. Go ahead, Ed.
Asphalt is, hot mix asphalt is the most recycled material on the planet.
Yeah, absolutely. And we don't want to throw it away. It's too good. It's too valuable. Even when it's alligator cracked and starting to break up, it's still pretty good stuff. But we got to do it correctly. We've got to use good choices. But remember, recycling fixes the surface. Okay, so if we recycle the stretch of roadway, if there's a base problem underneath, we're not doing anything to fix that. Okay. And of course, there's recycling trains, and they work very effectively. Okay. So we talked about this again in a previous webinar, and you can take a road that looks pretty bad. If it's got good drainage and you maintain it properly and you recycle it properly, well, that road can be pretty good when you're done. Okay. But remember, recycling is dealing with the surface, you know, just a surface crack, maybe an old pavement that's starting to get just worn out with age, maybe a patch or 2, but not major issues underneath. Okay. So.
And you also have to have enough material there to recycle.
Yeah, you can't.
Minimum 4 inches, hopefully 5. And unfortunately, a lot of local roads don't have that much material.
Yeah, you got to make sure you have enough thickness. And we'll talk a little bit about the thickness you need at the end of the process. And we did that with another webinar as well. And then the other thing people sometimes want to jump to is total reconstruction. Total reconstruction is very expensive. That's when we're essentially taking and starting over, throwing everything away, putting in the big piles. It may be the only option, but when you're done, you do have a brand new roadway, so I like it. Most commonly, we see reconstruct at the local level when people are putting in utilities and doing major utility work. And this is my OSHA slide, or lack thereof. We could spend a whole webinar just on this one slide almost. But the whole point is, if you're going to reconstruct a road, do it right. Okay, we don't want to use that famous motto, we do it nice because we do it twice. Let's build it up properly. And when you're done, you have a good roadway. Okay, this is actually a road on the Cornell campus that was built. Boy, it's about 19 years old now. And it does need a wearing course, but it's in pretty good shape. So what we're talking about today falls in that middle category between recycling and total reconstruction, reclamation and stabilization. It's almost a new road. It does repair the base, and it can be very, very cost effective, okay? But there's a couple of things to keep in mind, some keys. First off, you gotta pick good candidates and you gotta improve the drainage. If you can't do that, then it's not gonna be a good candidate. And then you have to choose the correct additive. You have to choose the correct technique for the reclamation at the end of the day, okay? What do I mean by that? Well, here's a chart. This is a textural chart that shows you the percentages of gravel, sand, and silt and clay in the base underneath the paved road and even on the surface, okay? It's one of the tech tips I mentioned earlier. What we want is we want the gravel content to be about 50 to 70% because that's where the strength is. We want the fines, the silt and clay, to be under 8%. And we need enough sand to fill in the voids. And so we'd like to be in the blue. But the problem is most roads started as gravel. And when we paved over the top of them, we may not have cleaned that quality of that gravel up, or it may have deteriorated over time. So if you think about it, we'll close up in on the good portion of the chart. If we've got a section of roadway, and let me make sure I got a yellow pen here. I do have a yellow pen. So if we've got a material that's a little bit dirty, it sits up in here in this dirty area. Might have made a good gravel surface, but it's not a clean base. Well, that's a good candidate to reclaim it and bring it down into the blue zone by binding up the fines, cementing the fines, or bringing in new gravel and blending it together so that when we're done, we're inside the blue zone, okay? Now, we're not going to get into the engineering techniques of exactly how that's done, but I do want to remind you that there are different ways to stabilize, to bring materials from outside the blue area into it, okay, by binding or cementing or mixing, okay? And so there's different choices. You could just pulverize the existing material and blend it all together, and when you're done, the blend is inside that blue zone. You could do mechanical stabilization, which is a fancy way of saying, I'm just going to bring in some rock, add it to what's already there, and when I'm done, I'm going to have a cleaner material. I could do chemical stabilization where I bring in calcium chloride, a salt, to help reduce the frost issues. I could bring in cement or fly ash to help bind things up, or I could do asphalt stabilization with bituminous products, emulsion or foamed asphalt, or a combination thereof, okay? We're going to go through each of these in more detail, but before I do, let me go to poll question number 2. And let me see, which ones of these have you done? So you can select more than one choice. So I'm showing you mechanical stabilization, calcium chloride, cement, lime fly ash, emulsion, or foamed asphalt. Which of those have you done, had experience with? And Ed, we don't get to vote.
That's okay. I never do anything. Just watch.
Just watch. So we'll see how many folks have clicked through here. We'll give them a couple minutes. Well, actually, we'll give them about another 20 seconds or so, see what people say. Probably should have put a none in there as a choice, but that's okay. Okay, so we're in the polling. Okay. And by the way, if you're wondering, and we actually do have a question in the Q&A pod, we'll answer those questions as we get time. We'll come back to this one that's in there right now, but put your questions in. We'd like to answer them. We should have time toward the end to be able to do that. Okay, so I'm going to share the results. So almost half the people that have done some kind of mechanical stabilization where they bring in rock and clean everything up or pulverize it, 40% with calcium of salts, 20% doing cement. That's more than you and I thought it might be, actually. That's actually good.
Yeah.
One person doing lime fly ash, We won't talk about that a lot. It's not commonly used in New York. It is a technique. I'll mention that later on why we don't use it much. Emulsion, about a third, and then foamed asphalt, one person with foamed asphalt. Okay. Okay, cool. That's useful as we're talking later on to know what's going on.
Maybe they did that cement one quite a while ago, though.
It's possible. It's possible. When we get back to that, we can ask that question when we get to the more of the details. Cool. Okay. So, you know, we can talk about different techniques when we're done. This was a demo we did at the highway school a few years back where we did cement stabilization. In fact, there's Lynn Irwin, the old director, as we were doing the road, and that's the product after it was done. And if it's done well, stabilization works really, really well, but you got to do it correctly. And if you don't do it correctly, you can lead yourself into trouble. So now I'm going to let Ed talk a little bit about the full depth reclamation process. And so I'm going to do my best to keep up with you, Ed, on the slides. It's all yours.
Sure, thank you. We're going to go into a little more detail about FDR right now. The New York DOT has a definition that full depth reclamation is a recycling method where all of the asphalt pavement section and a predetermined amount of underlying sub-base material are treated to produce a stabilized base course. It's a pretty good definition by an agency that really doesn't do much FDR, probably almost none, because they really don't have a whole lot of base failures because most of their bases are Portland cement concrete pavements. Just wanted to comment here that there's not a whole lot of work zone traffic control on this picture. Looks like an idyllic place to do some reclamation. So when, jumping around, Dave, when you use FDR, well, as Dave already said before, inadequate pavement structural strength. Mostly it's kind of one of your last choice treatments before reconstruction. You can't recycle a pavement that has severely inadequate structural strength unless it's in very localized areas. At that point, you're going to have severely cracked pavements. You're going to have pavements that have poor ride quality, bumps and holes and potholes, things like that, or some rutting and some corrugation, slipping, delamination and or stripping, and also some raveling and even bleeding. FDR can fix almost all of these issues. And what does it do? What do you end up with? Well, it completely eliminates pavement cracks. You can FDR to more than 12 inches, but that's pretty unusual. Typically, we'll go 6 to 9 inches. You're able to rehabilitate the existing pavement and some of the base without reconstruction. And what are we doing? Well, we're being environmentally green. We're reusing valuable resources, and it is cost effective. The most important thing is that we get the structural strength in the pavement back, I believe.
I agree with you. If you've got good drainage.
Well, you have to address the drainage first. You have to go out and recut the ditches if necessary. You know, find some areas where maybe there's some springs coming through, address the culverts, etc. Because if you don't, you're just you know, putting lipstick on the pig. But some of the equipment that's used for FDR, some of it is very specialized, and some you see it every day. This road reclaimer, it's very specialized. It's a big piece of equipment, 400, 500, 600 horsepower. It does a lot of things, and we'll get to it in a little while. The usual grader you see all the time. Rollers, some you see all the time, some that are a little specialized. Water truck, dump truck, stone spreader, and you've got to get the additives applied in a calibrated manner. Sometimes you do that with the Depth Reclaimer, and sometimes you do it out ahead of it. This is a schematic of a working reclaimer. You don't ever get to see this in action. I really would like to sometime. I don't know if you could put a video camera inside the reclaimer drum, but I think that would.
The body was pretty full of stuff. It'd be hard to see much. I got to see one being built in Chattanooga, Tennessee once, and they showed us the inside of it and how they were checking to make sure it spun. And that'd be tough to do. It'd be pretty cool though.
Yeah, yeah. Well, I've been underneath a regular milling machine while the guys changed all the teeth, and that's it's kind of fun to see. I mean, it's horrible to actually have to do it. Next, we're going to see another schematic of a reclaimer. This shows the actual operation. The machine is moving to the right. The milling drum is moving in an upcut direction. It's going down into the granular. It's a sub-base material, taking the whole pavement up. And if you notice up in the top there, there's a little injector where you can inject water and or fluid stabilization agents, calcium chloride, liquid calcium chloride, etc. Almost all the modern reclaimers now have those installed.
And this particular picture I noticed doesn't show the baffles. There have to be some baffles in here, otherwise you get too big of chunks. You've got to make sure that it gets ground up with these upcut machines. That's pretty
Correct.
important.
Yes, yeah, because the regular milling machines do use an upcut material, and they take the material away to be crushed for at a plant. Whereas if you do a recycling project, you got downcut machines that actually size the material better.
Yep.
Dave will talk about the additives that are injected into the drum a little later. So full depth reclamation, there's another, I got another definition for you. This one comes from Dave. It involves rototilling a road and blending the pulverized pavement with its underlying subbase or subgrade. Many times a stabilization such as asphalt or cement is added to increase the strength of the reclaimed base. It's a pavement rehabilitation technique in which the full flexible pavement section and a predetermined portion of the underlying materials are uniformly pulverized and blended together to produce a homogeneous stabilized base course. And if I got a little distracted there, it's because the town highway department's just going down the road in front of my house, patching potholes. And they do have a roller, and he's actually going to do more than one pass.
So he's compacting it. That's good to hear.
Absolutely, and I think it's definitely hot mix. Let's see, 3 passes, that's it. Well, hopefully it'll last. So during the construction process for FDR, analysis and testing is probably one of the most important parts of this, besides actually doing the work. Not all steps are in every FDR project. This is kind of a typical list. Usually the contractor will do the analysis and testing, unless you're a state highway agency and you have a lab that you can use. This is the kind of work that the contractor will do for you. But it's important to understand what's going on so that if the contractor says to you, I'm going to use X additive, you can say like, well, explain to me why, and you can have some possible understanding of what they're going to do. Pulverization is done by the reclaimer. You can apply and mix the stabilizing agents either in the drum or up ahead of the machine. Shaping and compacting is done with graders and rollers. You need to fine grade and compact again the stabilized material. Sometimes the surface is a little dusty and it needs to be primed, and then at the end you do a surface course. Now here's a picture of a much younger Dave in a test pit, and I'll let Dave talk a little bit about what the heck he was doing there.
This is part of that demo we did at the highway school, Ed, where we did the cement stabilization. And the thing about,
He
you got to do
certainly
a test.
seemed like a younger person.
I was a lot younger, had no gray hair. It's a lot less of that non-gray stuff left. But the key is you've got to do a test. You've got to get underneath and see what you've got. You can do cores. You can do a larger test pit, which I like. You can also just do a small, like a 3x3 square and dig down. But the key is you need good quality testing, and you need enough of it. That's probably the biggest issue I see is we try to do one test for a whole long stretch of highway. How many tests would you typically see in a mile, Ed, for the work y'all were doing?
It's 4 to 6, I believe.
Yeah, 4 to 6 is typical. So you may not do a test pit in every single case. Maybe you use small holes, most of them, but 1 or 2 test pits, especially where you're concerned about drainage or what's underneath, can be very helpful. So
we'll do 6-inch cores.
Yep.
And you do it 1.5. We'll talk about it a little later, but it's 1.5 times the depth of the FDR.
Right.
So candidate selection, low volume roads, less than 2,000 AADT, and that's kind of critical because maintaining traffic on these kind of projects is difficult, and you can't have 8,000 vehicles coming up and down the road while you're trying to do an FDR project. And
well, there are people who do them. I know there are. The challenge there is the traffic control almost as much as it is the QA/QC on the FDR itself.
Right. Well, it becomes cost ineffective if you have to do that kind of work. But people have done it. I've seen people do chip seals on I-95 in Virginia. So there are ways to do difficult projects. Sometimes you have to search for the solution.
Yep.
Groundwater elevation, and this is important. The groundwater it has to be below the subbase by 2 feet, or at least a foot below the bottom of the subgrade, because if you have groundwater coming into your project, it's a recipe for disaster.
And what'll happen there, if those who are listening, what'll happen is the water will actually be pulled up by capillarity right into your new material, and it'll be too wet and it won't survive and break down in the spring. So yeah, it's part of that drainage issue.
Okay. Now this is a little bit of what comes first, the chicken or the egg. You got to determine the full depth reclamation depth, somewhere in the range of 4 to 12 inches. Like I said before, it's usually 6 to 9. You can kind of, if you know the road history and you know how much blacktop is there, or if you know how much gravel is underneath, you can pick a number. But the number will be determined after you do the coring. Your core should be 1.5 times the depth you're talking about. So if you core somewhere around 12, 13, 14 inches, you should be okay. You got to do 4 per lane mile to get enough material. Plus, things change over the course of a project. You don't really know how many changes in road cross section there is, unless you've been on the highway department for a long time. And then once you've done the coring, then you can adjust your depth.
And so you may wind up sometimes purposely going a little deep with your cores just to be sure.
Absolutely. Coring is cheap. Usually the contractor does it. When I was with the contractor, we did coring for nothing. So, and even if we didn't get the project, when it went out to bid, that was just considered a cost of doing business. Now, this is where the contractor's lab comes in. They're going to test for moisture content, sieve analysis, hydrometer particle size analysis, and liquid limit and plastic limit. And this is kind of stuff that I've never done. That's really beyond my capability, but I know our lab guys, when I was with the contractor, knew it backwards and forwards. And when they came up with a recommended additive, it was because they were testing and finding out what was going on in the soil.
This is actually pretty important. We're actually just about to launch into a project where we're going to look at these techniques for choosing the stabilizer. We may add a test to this list on the sand equivalent. We're all said and done, but it's really critical to do these tests, because if you choose the wrong stabilizer, you can actually make the problems that you didn't want to go down in the first place. We'll talk about those when we talk about stabilizers.
Right. Yeah, I was going to say Dave's going to address all this. What you do with this, what the contractor does with these results a little later on picking an additive. Going to look at a few reclaimers here. This is one of Dave's photos. He told me it's an old Bomag. I've never seen this piece of equipment. It's got I'm sure it's got a milling head inside that container there.
The reason I like this picture, Ed, more than anything else, is to show that you can use FDR in some pretty tight spots. This is a dead-end road with no right-of-way. Literally, it's a road by use, and they actually were able to reclaim the road in an extremely narrow right-of-way. Almost a perfect application of FDR technique.
Okay. That's why you're using it. The next is a Caterpillar brand. There is a tanker in front feeding liquid calcium that's being injected into the milling head, and that's why the material looks a lot darker when it comes out the back of the machine. I'm not sure where this picture was taken.
It's a U.S. Forest Service road out west. It was actually taken by Lone Urban.
Okay. Looks like they're doing a nice job. I think the other side of the road has already been done, correct?
I think so, yeah.
And it's cured a little bit. Here's the old Bomag. I know a lot of people, when I was talking to town highway superintendents, have used Bomags in the past. This is basically just using some water. Looks like we got some drainage issues on this road. Hopefully they have addressed them, or they're going to sometime soon. You got any comments on that photo, Dave?
The main thing is that they were just trying to adjust the water content before they compacted it. You need to have the right amount of water. That's part of the testing process.
Absolutely, absolutely. Here's a show of the rolling operation here. There's a pad foot roller and sheep's foot roller, some people call them. I don't know how many people have actually seen one of those outside of reclaiming jobs. It's kind of used on deep soil compaction, because that's what it's meant to do. You got to get that pad foot roller up in the back of that machine as close as you can. And you end up getting a more concentrated compaction with a pad foot. Just the process for grading and compaction here again is a pad foot roller doing the first pass behind the reclaimed material.
One of the things important about the sheep's foot or pad foot rollers is they knead the material into place, and they maneuver it around as opposed to just rolling over and trying to press it down. So that's why it's pretty important to use that in the first pass.
Right. Well, like I said, it's done on deep soil layers, and that's what it's designed for. Actually, the sheep's foot name comes from sheep. That there were people that in probably jolly old England that used sheep to walk on paths and compact them, or they were just doing it as part of what sheep do. The grader follows up for the first pass after the sheep's foot roller. Picture of a grader here, garden variety grader. I haven't worked with any of these ones that are controlled by satellites, but it's quite an innovation, and I wonder if any of you folks have actually seen them yet, because they're making their way into the.
Well, let's see. If you raise your hand, if you've actually seen a satellite-controlled grader operation. See if anybody raises their hand here. A couple of people have.
Oh,
okay.
Cool.
But not many. Okay. It's coming.
It's coming. Yeah.
You never know. So.
They'll be driverless after that. And then after the grader, you follow up with a vibratory roller, typical garden variety, single drum vibratory roller. As I said earlier, FDR is usually done 6 to 9 inches. You can do 12 to 16. That's going to seriously slow down your production rates, which average anywhere around 25 feet per minute, which basically computes to 1 to 1.5 miles a day of a 2-lane road. And then afterwards, you need to apply a wearing surface. New York State DOT would apply 4 inches of asphalt, hot mix asphalt. I've seen people do double and triple chip seals. Unfortunately, and later we'll talk about costs, but if you do a double or triple chip seal, you got to remember to redo it in a few years. As the hot mix will probably last you 12 years with proper maintenance, where the chip seal, you'll be back there in 6 to 8.
Well, it depends on the traffic, and that's why you need to design the road to handle the loads and the thickness. And we talked about that in a different webinar earlier, making sure you get the right thickness. So,
I think I'm handing it over to you for the videos, Dave.
We'll start the video. Let's see the first video. There's no sound. Actually, I think let's see if the sound works. It may not. This is the soundless one. You took this video or shared it with us, so this is the reclamation machine just going down the road.
The Gorman reclamation machine. It's a work-in. It was pretty new a couple of years ago. It was brand new for them. It is a beast. It is a beast. Water truck.
Okay, cool. Going down the road, cutting everything up.
There it is there.
So were they adding anything other than water, or was it just water in this case?
I think it was, that one might have been water, or it might have been calcium. I don't, in the 10 years that I was with Gorman, I don't remember them doing anything but calcium. They have the capability to do emulsion and foamed asphalt, but you know, the costs were a little more, and most people really didn't want to do it. This video is not working very well on your machine, Dave.
Well, it's the nature of the internet.
Yeah.
Let's try the other one. See how this is the one from Vertkin, and we'll see if the sound plays today. It wasn't playing earlier this morning. Can you hear it or not?
I don't have it.
Nope.
No.
So in this case, I made sure I got the sound in my head. He's putting down the in this case cement ahead of time. That's what the white schematic is.
Mm-hmm.
Then they're adding water and other chemicals. And then they're actually sucking everything up into the reclamation machine. Same kind of one that was in the video you shared, Ed.
Yeah, the working.
Yep.
And if somebody, this is available on the internet.
And we'll link to it as well.
Okay.
That's the schematic of it.
Yeah.
And there's the injection spot you talked about earlier.
Mm-hmm.
That's why I don't think a video camera would see much inside here.
No, you're right. You're right. Hey, you can dream.
Yep. But it does mix it up pretty well. You can't go too fast, though, because if you go too fast, you'll actually get chunks out the back. So you got to keep the speed just right.
Like all pavement treatments, how many people have driven down a road where the contractor put down the hot mix to actually roll the hot mix too quickly, and you get the little undulations every foot from the vibratory roller being set wrong because they went too fast. They're actually using a pneumatic on this too, if you see.
Yep, they used the pneumatic roller. Yeah.
Right, and this is a completed project in very tight quarters. Like
that's the one that I showed you with the Bomac. where they paved it afterwards. So you can see it's pretty tight, and they were actually able to use full depth reclamation there. So
Great. Great.
So let's talk a little bit about the additives. We showed you this list earlier. I just want to go through each of these and talk a little bit about where they're used and why they're used. Pulverization. What pulverization is essentially is you just grind everything up, and at the end of the process, you mix the asphalt with the base, and hopefully that mixture has the right fines content. You're just pulverizing what's already there. That works really well if you've got a fairly clean base, but it's just either an old asphalt surface or just a little dirty and you want to clean it up. You might bring in some rock if you need to get the fines content down, but it's a fairly common. In fact, I remember about a quarter of you have, actually, no, excuse me, 45% of you have used that that are on the webinar today. You can add calcium chloride. This is best with well-graded material. You'd like to have low fines content, minus 200 stuff. The challenge here is you're going to add a little bit of calcium chloride to reduce the frost susceptibility. It helps with compaction and strength, but you're not changing the fines content at the end of the day. So keep that in mind. If you've got calcium chloride, you're reducing the frost issue, you're reducing the spring thaw. But if it's got too many fines, especially the wrong kinds of fines, it may not actually do what you think it's going to do. And if you've got a drainage problem underneath, it's not a good technique. But it can work very well because it reduces that frost action a little bit. Cement. What you're doing now is you're taking those fines and you're cementing the fines together as part of the process. All the small particles get bound up and you reduce the fines content that way. And it's typically 3 to 5%. The biggest issue I see with cement is too much. In fact, that's what happened with our demo. When they bring the truck with all the cement, they don't want to take it home. So they went ahead and put it on the job site. And now I had too much cement. And if you get too much cement, you get shrinkage cracks. And those shrinkage cracks now are a place for the water to get in, and that can be a problem. You do gain strength with cement stabilization, but again, if you add too much, you can actually get to the point where it can block crack on you, and that's not good at all. So you want to add the right amount, not too much.
And just to interject, that's a cement slurry machine there that Gorman got rid of before 2010. So
it's not as commonly used in New York as it used to be. Yeah.
Absolutely.
If you're adding dry cement, like they showed in the Vertkin video, that supposedly we're putting it down ahead of time, that's actually these days they recommend if you're going to do that, you put it down as a slurry. Don't put it down dry. This is where somebody was actually applying it dry, the powder, and it was a windy day. You're going to make a lot of friends this way. At least people are going to come visit you. You get phone calls, but
absolutely,
yeah. This is more common, where you mix it in a slurry and either drop it right into the whole reclamation train or put it down on the road and then grind it back up. Much more common. And then this is one of your pictures, Ed. This after they were done.
Mm-hmm. Yeah.
How long before they paved this, or did they hit it with a fog coat?
I'm sure they hit it with a fog coat because, you know, the paving is usually not, and the town highway jobs, the paving is a separate contract and it's controlled by the town highway superintendent. So, you know, you have to kind of protect the surface because usually the contractor is liable for the surface until it's overlaid.
Well, and even if they're coordinated perfectly, it may be a few weeks just because of other projects. So you want to at least plan for the ability to put a fog seal on there to protect that surface.
Absolutely.
Bituminous stabilization, this is where you're going to use either an emulsified asphalt or a foamed asphalt. In this case, you're not cementing the fines, you're binding them up. Okay, it's more of a binding kind of operation, but it still reduces the characteristics of those fines. You're going to add with emulsified asphalt, emulsions 2 to 5% by weight, with quite a bit of water in there, of course. It's got to cure out. So you need to do that just like you do with any emulsion product. You need to do it in the summer, not too late in the season because it won't cure out otherwise. And the moisture content is absolutely critical because you've already got water in the emulsion and you just add too much water, you can actually not have a hard time compacting it because now there's too much water in the mix when you're done. So that could be pretty critical. You may have to reduce the amount of water in the emulsion. In fact, sometimes they'll actually do that as part of the process. With foamed asphalt, similar, you're going to be adding in 2 to 5% foamed asphalt. You're going to also add a little bit of cement. Okay, that because you add that cement in, you don't have as much curing issues. You can actually, it cures out almost immediately, so you don't have that soil moisture issue as bad. It says no. It's really because the slide couldn't say. There's not much soil moisture. I was just reducing the text. And you get almost all the strength pretty quickly. And so that's actually pretty cool with foamed. And let's see if this slide will do today here. You going to play today? Nope, it's not going to play today. You're injecting air in when you inject the asphalt, and it foams up. Do you remember in elementary school, kid? Did you have Ed, milk that you got with a straw?
Of course, 3 cents.
Did you ever blow into it and make the bubbles?
Absolutely.
It's the same technique. You're just doing it with asphalt, and you're doing it at a lot hotter temperature, but it's the same concept. You're making big bubbles, and those bubbles have surface area, and that allows you to cover the asphalt, the rocks and the aggregate better. That's what you're doing with the foaming process. So it's pretty cool.
Yeah, the coating is almost 100%.
Yeah, and that's the key. You got to coat all the stuff that you want to take care of. And then the foaming process, very similar looking, just like we'd had before with a train, but instead of adding in cement, you're adding in foamed asphalt in this case. But again, just like with cement, you don't want to add too much because if you add too much asphalt, what do you think is going to happen? You've seen that happen, Ed? Have you seen it where they put in too much asphalt?
Rutting and flushing.
It's an unstable mix. It can actually create asphalt little globules that'll sit on the side of in the mix. It's a mess. So yeah, you need to pick the right candidate with FDR. How do I choose between the different choices? Well, again, it looked first at the fines content. You've done your test samples. You look at the fines content of the mixture after you're done. That mixture includes the asphalt that you mixed into it. So it's a mixed fines content. If it's low enough, you can just add rock, you're done. Assuming you don't have a really poor silty material, that's where the plasticity of the sand equivalent comes into play, where you want to have good, no plasticity in your mix. If you've got 10 to 15% fines, we want to get that down under 8, preferably under 5 for the fines content. So you could add in some asphalt to help bind up some of the fines. Again, as long as you don't have too much plasticity. The key there is if it gets too much in the way of fines, then you have a problem because now the asphalt gets all absorbed by the fines and doesn't really do the job of coating all the rocks. So that's why there's a limit, an upper limit there. And there's not much point in doing it if it's a low fines content. You might as well just add rock or calcium. Calcium, it can work as high as 20%, but realize you're still going to have a fines problem. And so if you've got a drainage problem underneath, you've got a lot of water issues, or if it's too thin, calcium may not do what you think it's going to do. It'll help with frost susceptibility, but it's not going to make it any stronger the rest of the year. So it has its place. Cement works pretty well, 12 to 20% with some tricks you have to do depending upon the plasticity that are involved. And again, lime fly ash, the reason we don't typically see a lot of it here in New York State, even if we were doing it a lot of the other techniques, is you have to have plasticity. You actually need the plasticity for the lime fly ash to react. And if you don't have it, you're going to have a problem. It doesn't actually create the binding that you need, the cementatious chemical reaction that you need. Ed, when you worked for DOT, what was the typical plasticity of most of the base gravels that you were putting down?
Not my area of expertise, Dave.
Yep, it was low, I can tell you that. They actually, DOT did a testing thing. They tested 100 sites, and the plasticity of base gravels, not the subgrades, never above 10 or so. And so you'd have to get into the subgrade, and even the subgrades for most of New York State aren't that high. Maybe up in St. Lawrence Valley, maybe in Fort Edward, up in Washington County. and some limited places along streams, most of the plasticities in the state are pretty low. So you'd actually have to make this work, you'd have to actually bring in something with high plasticity. And if that fails, boy, that's going to sound really good when you told somebody, well, we had to bring in clay to make this road work. Yeah.
Recipe to get fired.
Yeah, recipe to get fired or lose the election. So yeah, that's why it's not used commonly. But it is a great technique if you've got a high plasticity subgrade or base material that you're dealing with. So Ed, I'm going to let you talk a little bit about the cost.
Okay. Most people would say that FDR is relatively inexpensive. You get to treat 6 to 9 inches of the pavement and base material for $1.50 a square yard, plus your additives, which usually add anywhere from $1 to $3 a square yard. And that's all well and good until you have to put your overlay on there. And your overlay cost is where the money really is. Double or triple chip seals will cost you anywhere from $4 to $6 a square yard. And hot mix will be somewhere around $10 to $14 a square yard with hot mix at $60 a ton. Now, in order to prepare myself for this, I took a look at some bids through OGS for hot mix asphalt in place, and the numbers were just all over the place. It was anywhere from $60 to $95. So I use 60. If you're at 80 where you are, well, you can just do the math. But remember, you still have to consider proper maintenance for the overlay after it's done, which is chip seals have to be redone at certain time intervals. And the hot mix is going to have to be crack sealed probably a couple of years after you do it. If not, take a look at it and make sure that you're right on top of those cracks when they do develop.
Well, the thing about this is when you're done with FDR, though, is you've got a base that can actually now help carry the load. That's the key at the end of this process. So if you just wanted to overlay a poor quality base, you might have to put 6 to 8 inches of asphalt. And even if it's at $60 a ton, which, by the way, that's a really low price, it's a lot cheaper to do FDR than it is to have to put an extra 2 to 4 inches of hot mix asphalt to carry the load. So
absolutely, you have to do a cost analysis ahead of time. You can't just say, well, this road is in bad shape, let's overlay it with 6 inches of asphalt, or let's jump in and do an FDR or a reconstruction.
Yep. And by the way, in the Q&A pod, Ed, somebody just popped, they were on Long Island, they're paying $140 a ton. I hope that's in place, but even then, $140 a ton.
Wow.
Yeah.
Wow. And crude oil is cheap as heck right now. I don't know what's going on.
It's a combination of labor and shipping. It's just hard to get good aggregates.
Well, I know on Long Island it's tough because all they have is sand and they have to bring in them. But I mean, across the state, crude is I know it's come back a little bit, but it's not the numbers it was.
Well, the good news is we're talking about paving next week in our webinar, so we'll get to that. So, yep. Okay, so let me clear these. What we want to do now is we're going to talk about candidates. We're going to have a little bit of fun here. Let me get this moving over. Okay, so what we're going to do now, we're going to have a little bit of fun with you. We're going to show you a picture of a candidate, okay? And then what I want to do is have you tell us whether or not you think this is a good candidate or not. So here's a picture. We'll talk about it briefly. We've got enough time to go through a few of these. So is this a good candidate? Yes, no, or maybe you're not quite sure. So if you could vote, please. There's no right or wrong answer. We're not recording these. Except for Gary Nelson, we're going to record yours. Okay, I'm going to get to at least, I'd like to get to at least 60%. There we go. Okay, look, watch this, Ed. All over the map.
Yeah. I would have voted maybe myself. Only because you better treat that drainage issue you got.
Yep. And that's a classic example why you can't just look at the surface. You have to do the test, because without knowing what's going on underneath, why has it got that drainage problem? Is it just age? Is it a lack of ditches? Yeah, and absolutely, you've got to do a test, okay? Okay, ready for the next one there? Let me stop these results. We'll come down here. Okay, I'll relaunch the polling. Okay, let's try again. You think that's a good candidate or not? Got less maybes this time, Ed.
I would think you'd get more yeses, but I don't want to cheat.
Well, we got enough here. We'll share the results. Almost split. Look at this. 45%, 14 people voted yes, and 13 people voted no.
Pretty close, pretty close.
Yeah.
To me, you can see the alligator cracks in that. You can also see that I don't know where the water's going. But it doesn't look like there's any real terrible issues with standing water. The crack filler material will certainly be ground up by the reclaimer. So again, you got to do some cores and see what you got. But to me, that's a good candidate.
Well, it depends what's going on underneath. I happen to know in this particular case, this is actually a better candidate for recycling. It's just an old pavement in a residential area, and it's just gotten alligator cracked over time more than anything else. It's strong enough, and if it's strong enough, you don't need to do anything with the base. You could just recycle that surface, or mill it and fill it, as one person put in the Q&A pod. So somebody else put in there, is that a good candidate for heater scarifier? Possibly, as a technique. The challenge for heater scarifier in that particular case, because it's residential, I don't want to burn the grass or the flowers, but it's a possible.
Depends on overhanging trees too.
It does depend on overhanging trees, yeah. So that's why it's important to have a history, to know how old this is. The one thing it was definitely was not a good candidate for what they did do, which was crack repair. So
looks like they missed most of them too.
They did. It's pretty sad. So okay, next one. You know this one better than I do. I'll relaunch the polling and we'll see how they come up here. Do you think this is a good candidate? I'll get to at least 50%, and then I'll end the polling, and we'll see how we do here. Okay. Okay, Ed. About half said yes, 40% said no, and a couple said maybes. You know this road better than I do. This is your picture.
Yes, and I agree that it looks like a good candidate from the surface. Now, there's definitely something going on in the center of that road. I haven't seen many roads crack quite like that. You got to get down there and investigate what you see going on. I certainly wouldn't just mill and fill it. And you might be able to recycle it, but you got to see what's happening underneath. It looks like there's ditches. So,
yep. Well, and that's why the test is so critical. This is a case whereby, Ed, I would actually recommend the test pit rather than just cores, because what you want to be able to do is get a cross section, and it's possible we've got frost issues underneath. It's possible we've got some frost heaving going on. You can't just tell that with cores. That's why I'm a fan actually of a test pit in this particular case, where you start at the center line and go out to one side. So you could detect, maybe figure out why those cracks are there. They look like frost cracks, but until you do a test pit, you don't really know. It could just be an unstable asphalt mix. Again, that's why one test is worth 1,000 expert opinions.
Absolutely.
Okay, let's go to the next one here. And I'll relaunch the polling and see what people think. Okay. And we'll end the polling and share the results. Again, it's your picture, Ed, so I don't know the history of this particular stretch.
Well, to me, this is a very good candidate. I mean, you could see the distress, you can see the cracking all over the place, you can see the potholes. It does have curves, so obviously there must be some catch basins south or north of our picture here. But you're not going to get by with just recycling this. There's some definite failures of the base that you can plainly see. Again, you got to do your cores and find out exactly how you're going to treat it. But to me, it's a good candidate.
Well, and then a good question that came up in the Q&A pod, what would cause this kind of cracking? Well, it's an alligator cracking, and that's a fatigue crack. It could be caused by long age, just hasn't been repaired. It could be caused by a base failure underneath. It could be caused by a drainage problem underneath. That's why history and some tests are absolutely vital to really know. The thing about FDR, you cannot tell precisely what to do until you've done the test. It's just the nature of the beast. Now, on the interest of time, we're getting close to our hour, and we had a whole bunch of choices for candidate selection, but we also understand your time. So we'll have a little bit of fun here with one last candidate here. We'll relaunch the polling one last time and see if anybody else has any comments in the Q&A pod.
I don't know if they saw it though, Dave.
I can move it. You can move it. You can drag the thing out of the way if you need to.
I'm still learning these Zoom stuff.
I know, it's okay. Isn't technology fun? So we got about half people voted here. And we'll end and share the results. So some say yes, some say no. Okay. And a bunch of maybes. I think I would be a little bit worried about our friend Mr. Gator there myself.
Well, it's a very, very short little photo of you don't know what else is going on the rest of the road. So I think maybe it's a good idea.
Yeah. Well, and that's the whole point is we need to do tests. We need to look at it. FDR is a great technique. It has its place, but it's not a perfect candidate. Okay. So again, I got one question in the Q&A pod we'll answer real quick. Thanks, Ed, for joining us. I hope you've enjoyed this. It's been a little bit of fun.
Yeah, you're welcome.
And we have a webinar next week on paving. So now we're going to put a surface on top of our FDR roadway next week with paving. And there'll be a companion video to go with this and then a shared surface panel week after that. So the question in the Q&A pod, and then we'll let everybody go, had to do with concerns about getting contractors involved. And Ed, that's why I wanted to bring it up. The question has to do with how do you get contractors more wanting to do different types of FDR testing? Any thoughts about that?
Well, contractors want to get work. And, you know, when I was with the contractor, if one of my customers, one of the people that I went to see asked for a test, we did it. We wanted the work, and when we did the testing, we offered to let anybody come in the lab that wanted to come in the lab, and actually we did set up some lab tours, which I thought was a good idea, and so they could see exactly what the tests were, and you know, the contractor is at least with the one I was working with is interested in repeat business. So they're not going to sell you a product that's not going to work and then walk away and hope to get your business back. And like I said, the guys in the lab that we had, guys and gals, knew their stuff, and were certainly happy to share it with anybody.
Well, the note here in the Q&A pod says that the concern was they're worried about meeting the quality control guidelines after they did the testing. Any thoughts on how that can be overcome?
Well, if you want to really spend some money, you hire a consultant to do the inspection on the project. But other than that, then, you know, you could call your local representative from the DOT. There are local roads representatives in each region that could help you out, or call Dave.
Well, we can help out, and certainly I'll follow up with the person who put in the Q&A question. Maybe it's the size, maybe it's a risk issue. The thing is there maybe is look at your spec. And it might be the DOT spec is designed for a big job, and this isn't a big enough job, or it may be that they're just, maybe there's some way we could tweak the spec. Because at the end of the day, the contractor wants to be able to make money.
Oh, yeah.
And if your spec he can't feel like he can make money, yeah, he's gonna be reluctant to bid. So can't blame him there. Okay, with that, I think we're a little bit over. I apologize for stealing 3 minutes of your day, but it's a nice day. Get outside and enjoy it. And good luck. We will see you next week, hopefully, when we're talking about the paving surface. And with that, thanks, Ed.
Thank you, and have a great day, guys and gals.